Today we will be talking about how to integrate using partial fractions. Let's say we have the integral of 2x plus 1 divided by x squared plus 5x plus 6. To integrate this, we will use partial fractions, where we basically factor the whole fraction then break it up to multiple fractions which are then easy to integrate. The first step is factoring the denominator, which is a simple trinomial. So we need two numbers that multiply to 6 and add to 5, and these numbers are 3 and 2. So now our function will be 2x plus 1 divided by x plus 3 times x plus 2. Now we break the function into two parts since we have two roots, so we will have a over x plus 3 plus b over x plus 2. Now we will find a and b using a method called Grubby's thumb rule. To find a, we will cover x plus 3 in the factored function and sub negative 3, which is the root, into x everywhere else in the function except for x plus 3, because if we subbed it in there, we will get 0 and therefore the denominator will be a number over 0, which is undefined. When we sub in negative 3, we get that a is equal to 5. Now for b, we cover x plus 2 in the factored function and sub negative 2 into the rest of the x values in the function, which then we get that b is equal to negative 3. Now that we found a and b, we put our functions that is now divided into the partial fractions in our integral. Now we have a 5 over x plus 3 minus 3 over x plus 2, and if we factor 5 and 3 from the fraction since they are coefficients, we will get 5 times 1 over x plus 3 minus 3 times 1 over x plus 2. As we know, the integral of 1 over x plus 3 and 1 over x plus 2 is just ln of the absolute value of x plus 3 and x plus 2. So our final answer is 5 times ln of the absolute value of x plus 3 minus 3 times the ln of the absolute value of x plus 2 plus c, which is just the constant. Let's look at another example. We have the integral of x squared minus 3 divided by x times x minus 1 times x plus 3. Since this function's denominator is already factored, we can jump straight into dividing this function. Since we have 3 roots, we will have 3 parts. So we have a over x plus b over x minus 1 plus c over x plus 3. To find a, we will cover x from the function and sub 0 into the rest of the x values in the function, which we then get that a is equal to 1. To find b, we will cover x minus 1 from the function and sub 1 into the rest of the x values in the function, and we get that b is equal to negative half. To find c, we will cover x plus 3 from the function and sub negative 3 into the rest of the x values in the function, and we get that c is equal to half. Now that we found a, b, and c, we put them back in our integral that is now 1 over x minus half over x minus 1 plus half over x plus 3. Now it is very easy to integrate since we broke the function into smaller pieces. The final answer is ln of the absolute value of x minus half times ln of the absolute value of x minus 1 plus half times ln of the absolute value of x plus 3 plus c. Let's look at one more example. We have the integral of x squared minus x plus 1 over x squared minus x minus 2. Now to use Grubby's thumb rule, the highest degree in the numerator must be less than the highest degree in the denominator. It cannot be equal or greater than. In this case, we see that both the numerator and denominator have the highest degree of 2, which means that we first have to do long division to make the degree in the numerator less. So we will do long division, and we can see that x squared minus x minus 2 goes only once into x squared minus x plus 1, and our remainder will be 3. So now our integral will become 1 plus 3 over x squared minus x minus 2. Now that the degree in the numerator is less than the degree in the denominator, we can continue to use Grubby's thumb rule. We first factor x squared minus x minus 2, and get 3 divided by x minus 2 times x plus 1. We have 2 roots, so we will break this function into 2 parts, which are a over x minus 2 plus b over x plus 1. To find a, we will cover x minus 2 from the factored function and sub 2 into the rest of the x values in the function, and we get that a is equal to 1. To find b, we cover x plus 1 from the factored function and sub negative 1 into the rest of the x values in the function, we get that b is equal to negative 1. Our next step is subbing these values back into the integral, which is now 1 plus 1 over x minus 2 minus 1 over x plus 1. We integrate this and get that the final answer is x plus ln of the absolute value of x minus 2 minus ln of the absolute value of x plus 1 plus c.